Guys, Bukula here, gonna give you a video. I got you guys. I just want you guys to understand this word because this word gets used a lot in our community. It's called perihelion. Essentially, what perihelion is the closest any object is in its orbit around the sun. It's the point at which it's closest to the sun. Okay, that's what that means. So when the Earth is at perihelion, it's as close to the sun that it ever gets. So you'll hear that word a lot in this community, but a lot of people don't know exactly what that means. But that's why I'm showing you this, because what we're going to talk about is this comet, 168P. Okay, it's going to be visible on Thursday, guys. Anybody that has a chance, go outside and check this out because you'll be able to see it with your visible eye, without any help from a telescope or binoculars. Obviously, you'll get a better look if you use one of those, but it's going to be best viewed up in the UK for our friends over there across the pond. But anyway, that is happening, okay, and it comes into the subject. Obviously, a lot of people will probably get some comments about, hey, we just had that sundiver comet. Does this have anything to do with it? No, this is a different comet. Okay, it's not the big one that broke up and that little fragment that hit the sun, okay, or went towards the sun. This is a totally different comet, at least what we're told, and I can believe it because we get these kinds of things all the time. Anyway, you're going to be able to see it in the constellation Perseus, which is pretty much what they're saying here. And in case you guys don't know what a comet's made up of, I'm sure they can be made up of different stuff, but essentially it's a big ball of ice up there, traveling at very high speed. If anybody can remember, Halley's Comet comes around every so often. I was young when it came through for me. Chances are I'll probably not be on this Earth when it comes back around. Can't remember what the actual orbit of that comet is, but I know it's kind of long, so a lot of people only get to see it once in their lifetime. Then there was that Hale-Bopp comet that everybody, killed themselves because they thought they were going to be able to catch a ride on this comet to get to heaven. Okay, it was called Hale-Bopp. It was big national news, probably worldwide news. It was basically a cult compound that did that, being led by some crazy dude. Just go Google Hale-Bopp and you'll get all the information you'll ever want on it. Here's just a little star map showing you where this is at. Obviously, you guys can zoom in or go to your own star programs and find it. I'm sure it's going to be. There's already a bunch of articles written on this thing. So, again, it's going to be 1.37 astronomical units away. What is an astronomical unit? Okay, I've gotten questions like that before. It is the distance between us and the sun, and they use it as a measurement tool. Okay, that's an AU. So you'll hear them talking about, especially when they're talking about distances in space, they're going to say it's AU or like light years. But AU is used also. And so is lunar distance. What that means is distance between us and the moon. All right. Now we all kind of vary there a little bit, and they've just assigned like a really close number to that. I refer to the sun being 93 million miles away, but an AU is like 92 million point something. So that's my point there. Now, just another article. It's talking about a fire cloud. Yeah. Okay. This is what this looks like. All right. First thing I'm going to say, guys, is that I'm not sure if I buy this story 100%. I mean, I can definitely see how this could happen because they've actually, described how they think it happens. I'm not sure if it's in any kind of meteorological textbooks or anything like that. But for me, I have a hard time buying the whole thing, wholeheartedly. But on the other hand, I can actually see how it could be possible. All right. So essentially what it is that they're saying that these wildfires are causing this. Okay. Now we had a NASA plane, I'm not sure if it was intentional or accidental, flew through this thing. Okay. Not sure if they meant to do that or not. You know, whenever we talk about that organization, we always question, right? And we should. We should be highly skeptical. But when we do see things that we think might be correct, we can't deny that either. Okay? That makes us, you know, being dogmatic in a reverse way if we can't even entertain the fact that they might be actually giving us some truth. Okay? You can't just automatically think it's wrong. And I understand. I really do, because it's easy to do and it's hard not to feel that way. But that's just my opinion on that. But this stuff forms right above these wildfires. And then it makes the sun obviously look like that. Alright, so that would kind of freak you out. I'm just telling you. People who were looking at this were probably like, oh my gosh, what the heck is this? But anyway, it tells you here what it actually is, and how it's formed and all those types of things. That pic was taken on the 8th. So, you know, we'll leave it at that. But the next thing I want to talk about, guys, is this graph. We're having some disruptions on our magnetopause that I don't think it refers back to a coronal hole. If it was, that, you know, we do have a coronal hole, but what I'm saying is this graph, we're seeing conditions outside of what they predicted. That's what I'm trying to say. Okay. Now, I took a screenshot from yesterday and today. They changed this graph daily because it's a forecast map like a weatherman, right? So the first one I seen was this one here on top. Now, how do I know it was yesterday? Well, they put a timestamp on it when it was created. Okay. So, this one was created at 2000 hours. See here, 8:20. This is the newest one. Sorry. This is the one that was put out today. Now, if you go down here, it'll say the 19th. See it? Okay. So, and then what I'm trying to show you here is the difference between these two graphs. Okay. If you look at the 20th, which is basically where we're at right now, these are the conditions we should be seeing, and we're not. You can see the velocity down here on the bottom. It's not what we're seeing. Okay. So if we go to today's, what's weird is if you look at this, it's kind of a gradual taper. Now if you go to this one, you can see how it just completely falls off fairly quickly. Okay. Steadily. In other words, there ain't no waves or mountain looking like it is up here. Okay. So I just want to show you that, and you know, and also we're experiencing higher wind levels than just 400. I want to show you that too. So, but anyway, I'm going to pause here for a second, guys, and queue up some. All right, guys, I'm back here. Got you over at ISWA. Okay, ISWA. These are our magnetopause models. Okay. Now, like I said, guys, we're seeing disruptions. Okay. So you're going to see some crazy stuff going on here. Okay, obviously, we know that ain't right. Okay, that's some serious energy. All that red out in front. I find it interesting too, guys, that when this got close, our bow shock disappeared on the sides. It's like the Earth kind of redirected its stuff that direction to kind of help fend off what was going on. But I could be wrong on that. Obviously, that's a bam hit. Okay. And what I find interesting, watch this. Gets past us. We shake a little bit, right? And then see how our bow shock regenerated? You see that, how it was recovering? That's what it should do. Okay. But what concerns me is when we get waves after waves that are too close for that bow shock to regenerate itself, because it leaves us open in the front. Not completely, but close to it. So if we get waves close to each other, then you can see how more energy gets through. Okay, I've tried to talk about that in the past, but that was just a good explanation or good visual to see what I was talking about. See how it comes back? Now, I'll just keep on going here. I've seen these signatures before too. You know, typically stuff when it comes off of the backside here in a magnetopause, it should be like this. Okay, not like this. That's what it's doing right there. So what's causing it to bend like that? Well, it could have came in at a weird angle. It could have been pulled from something, maybe. Because remember, we're talking about magnetics here. Okay? Could have been pulled from something down here. Don't know. I tend to think, no, well, actually, guys, I don't know what I think on this. Okay? This is just a hard thing to kind of get to the truth. And again, we also have to keep in mind this thing picks up charged particles, but it can't tell you where it came from. It doesn't know the source. It just knows that it's charged particles. Now, what I want you guys to pay attention to here is how this started right here. You're going to watch it take a turn down. Okay? See how it starts in the middle? Right about there. See how it starts bending down some? Okay, then it just flips out like that, right? That jump again, guys, is just it going into safe mode and coming back up. I would expect that when we get big hits like this. Now watch what this is. I find it very, very interesting that we're seeing an increase here like we typically do. But usually when this happens, this teal color or whatever color is appropriate there is pretty much solid all the way down. Well, you can clearly see that ain't what's going on here. Okay, you can see this is what I'm talking about. And I'm gonna show you something here too. See how we didn't really get hit in the front when that happened? And you can also see this. I'm finding this very interesting because I've not seen this do this like this. I'm going to take you guys back another day in my next video and show you what I've seen there. But watch these. Okay? You're going to see them go up and then come back in and meet in the middle. See that? Now watch this. They separated back out. I find this very, very odd. Comes back in, and when they come together like that, they should shoot off just like this thing did. Okay, that would be normal, but this didn't do that. It went ahead and spread it back out and then went out. See that? And also, you can kind of see here where it tried to reconnect again. I'm using connection very lightly. It's really not that. It's just the intensity, right? But that intensity of whatever magnetic disturbance is there is coming together here and not back here like it usually does. Okay? I find it very odd. And then boom, obviously, crack, crack. I mean, look at all that, okay? I mean, it's like it's non-stop. So, I wanted to show you guys that. Now I'm going to show you the other ones real quick. Now, this one here, I did find very interesting again because of, see how we're getting hit in the front? All right, you see that happened real fast, right, guys? So if I slow it down, see how we compress all the way into the satellite line? And then the very next capture, rapid expansion, but it expanded in such a way that it did that. Okay, it pretty much flattened out our bow shock. Okay, and then it disrupted all this back here where it just kind of exploded outward from each other. So as I say that, watch it again. Okay, now watch this. It's going to tilt. The front's going to tilt up. Okay, we go back here. Hit. All right. And it tilts up. See it tilt? Now it's hard to see, but it did. All right. Now look at all that. That's kind of crazy, right? So we'll look at this one. This is the actually solar. This is the solar wind map. The arrows show the direction the wind's traveling. Now, right off the bat, I want you guys to look. 631 is the solar wind speed according to this. If this is true solar wind speed, which I don't think all of it is. Again, I think we're having reactions from other magnetic fields out there reacting with the sun, or not even reacting with the sun, just shooting energy off of itself towards us, creating its own wind. Okay? So we'll just drag this through. You're going to see pretty similar stuff. And again, see how everything's different up here in the top? Nothing's symmetrical here. Alright, now obviously this one's doing the same as the other graph did. Okay. See how it just keeps doing that? Alright, this is just really, really interesting. And it's not stopping. Okay. But yet our models are showing that it should have. So yeah. Alright guys. I'm going to show you this. This is the other magnetopause models. This is the density one. Okay. This is what I think is causing all this disruption. You see that right there? See how that dipped out right in here? That means we're getting hit pretty good with some high density material. Alright. You can see the waves coming in. You look up here on this chart. The darker means it's more dense. Okay. So, and earlier when I looked at this, right before this happened, the whole screen was pretty much white, which meant hardly any density. Now, if we go up here and look at the velocity, okay, it is moving some, but it's not nothing drastic. Okay, you see those little waves come in. Excuse me. But yeah, then you can go down here and look at the pressure one if you really wanted to get into it here. But you're going to see how it builds. We've all seen this thing act like this before. But yeah, it's just kind of crazy. Now, what I'm going to do now, guys, is take you guys over here to this real quick. Oh my goodness, where's the tool whiz? There they are. Okay, sorry about that, guys. But remember when that sun diver came in on the 15th? And I said it kind of looked like, you know, our object may have helped pull this thing in to the sun because of the actual curve as it came in. Because it did from a certain perspective. The tail of it turned into a backward C. Okay. Now, you know, sun divers can do that, I would assume. But to do it like it did was weird. Because it was kind of like it came, you know, say this is the sun. It was coming this way. Well, as it got close to here, it just kind of went whoop. Okay. Instead of doing this. That's my point. Okay. You know, if it was getting drawn in, it should have been getting drawn in at the same angle until it actually got into the sun's atmosphere and burned up. Or got close enough to where it did burn up. Okay. It should have been a straight angle, is what I'm trying to say. But it wasn't. It was straight. And what I'm saying here is I went back and went through some of that data. You guys see that? That's right where it should have been on the 15th. We've talked about this already. But that line underneath there is the actual sun diver. Okay, so this came in right by that thing. Now, if it did that help draw it in, I kind of think it did. That's just my opinion. I'm sure there's others out there, and I won't argue with them. But what I'm trying to say is, I really think this has something to do with it. But I wanted to show you guys that. So anyway, I'll give you guys an update here on the end of this video. Check out that comet, guys. It's pretty cool. Fire clouds. You know, believe what you want on that. I don't know. I'm just giving you guys the data that I'm seeing, the observations and the articles that I can read and those kinds of things. But yeah. So God bless. Yeshua saves, and you can drink this Kool-Aid.
Oh man, this is really living.
We're committed to the art and nothing stop us, not even a train, plane, tractor, all of us as we feel the rhythm, sound the marrow of our bones.